All right, welcome to the notes on quadrilaterals. This is going to go kind of quick today. If you can't keep up, feel free to pause the video so that you can write down the rest of the words, or just pause the video and put your head down and bang it against your desk. All right, welcome, sixth block geometry. All right, characteristics of quadrilaterals, couple things. It's a four-sided polygon and its interior angles add up to 360 degrees. These are both things we know. Then down at the bottom, we're going to list the 6 quadrilaterals that we've been working with. That's trapezoids, kites. I put parallelograms on there, obviously, rectangles, rhombus, and squares. So these are the 6 quadrilaterals that we have been working with. All right. Things that we know about parallelograms, okay? Things that we know to be true. So we know that both pairs of opposite sides are parallel, and we know that both pairs of opposite sides are also congruent. Things that we know about the angles. We know that both pairs of opposite angles are congruent, and we know that consecutive angles are supplementary. Okay, so these are all things that you already know. You can probably copy that from old notes or just write those down because you already know them. 5 ways to prove a quadrilateral is a parallelogram. So we're going to list the ways and then we're going to draw the pictures. I think the pictures are as important as the words, if not more, so that you can recognize these when they come up. So let's do them one at a time. Both pairs of opposite sides parallel. Okay, so if we have both pairs of opposite sides parallel, I'm going to mark those. If we have both pairs of opposite sides congruent, okay, I'll mark those. We could have both pairs of opposite angles congruent. So that one and that one, here and there. One pair of sides both congruent and parallel. So if this were congruent and parallel, that's a parallelogram. And lastly, the diagonals bisect each other. So we'll draw in the diagonals. And we mark them, their parts congruent. So those are the 5 ways to prove a quadrilateral is a parallelogram. And they're parallelogram. Unless you're in Miss Monroe's class, Miss Monroe says parallelogram because they don't know how to speak in Long Island. My class doesn't laugh because they don't know that's funny, but that's true. If you're no, you missed your chance. A rectangle. So a rectangle is a parallelogram. So all the things that we've already written. So this is where you're probably you don't have to write as much. The things that we wrote earlier about a parallelogram, they're still true. Okay, the opposite pairs of angles and sides being congruent, and the sides are also parallel, and the consecutive angles are supplementary. That's all still true. The big difference for a rectangle is what? Hopefully, people watching the video said that that it has 4 right angles because you guys all graduated first grade, so you know what a rectangle is. No, that's not funny either. That was almost sad. Okay. So what can you determine from the picture about a rectangle? So we're going to label stuff we know and see if we're able to determine something about a rectangle from the picture. So we know we have 4 right angles. We know that the opposite sides are congruent. From here, I want to show you something. We know stuff about the diagonals bisecting each other also, but this is where we have enough now that I want to show you something. We have one triangle right here. Okay? And then we have another triangle, we have another triangle right here. If you look at those 2 triangles separately, one of them is like this, and one of them is like this. What do you know about those 2 triangles? They're congruent, okay? Because they're congruent by CP/CTC, we can say that these parts of the triangles are congruent. So the new thing that I know about rectangles is that the diagonals are congruent. Not only do they bisect each other, so that is congruent to that, but all of the parts right there in the diagonals are the same. It's a big deal thing. It comes up a lot about rectangles that not only are the diagonals, not only do they bisect each other, but that they're also congruent. So some example problems with rectangles, and I'm going to go pretty fast through these because I can. Nope. That's 90 and that's 90 because it's a rectangle and y equals 10. So I mean that's easy stuff. If you look over here at the one on the right, you know, there's a ton of variables there and only one angle, but because of what we know about a rectangle, we know that that's congruent to that. Those 4 parts are all congruent. And we know that this is congruent to this and this to this. What we end up having that you may not realize is that this triangle is congruent to this triangle, and this triangle right here is congruent to this triangle. What we can do from that is we can do all sorts of problems just from one angle. So if that's 20, if this angle right here is 25, so is G, so is D, and so is C. I know that the angles in the corners are all 90, so I know that A is 90 minus 25, which is 65, which makes B 65, which makes E 65, which makes F 65. Then I know that these triangles right here, that's 50 degrees, so all that's left is 130 for H. Vertical angles makes J 130, and then linear pair makes K 50 and I 50. So all from one angle I can figure out the rest of the missing parts. On the last one, because I know that all the diagonals are the same measure, I can just set 5y plus 2 equal to 3y plus 12, and I get y equals 5. Not 5. Whew. 2y equals 10, y equals 5. Yeah, that's right. Door shut scared me. All right. Next. So more examples. Again, the problems look difficult, but if you remember, this is 12, so this is 12. MS is also 12. ST is also 12. AH is just 12 plus 12, so that's 24, and so is an MT and AH are the same. So 5 blanks, but nothing really difficult about those problems. Here we have EGO is 5x and OGM is 4x. Well, I know it's a rectangle, so 4x plus 5x equals 90, so x equals 10. On the bottom one, we have BD is 6x minus 10, so the whole thing. So on the last one, we have BD is the whole diagonal. That's 6x minus 10. It says that BE is 2x plus 8. Well, I know that this part, BE, and DE are the same. So that's also 2x plus 8. So I can say 2 times 2x plus 8 equals 6x minus 10. If I divide both sides by 2, I'm left with 2x plus 8 equals 3x minus 5. If that's confusing to you, the algebra there, please talk to your teacher about it. And x equals 13. Let's take a look at some more. So here we have rhombuses. A rhombus is a parallelogram again. So all the stuff we know about parallelograms, all still true. The big difference between parallelograms and then rhombuses, rhombi, rhomboids are all correct, plural forms. What's the big difference between a parallelogram and a rhombus? Very good. All the sides of a rhombus are the same. Okay? What we're able to do here, so let's mark what we know about a rhombus. All the sides are the same. Okay, so we know those are equal. We know the diagonals bisect each other. So if we do the same thing we did earlier with a rectangle, if we look at this triangle and this triangle and this triangle and this triangle are all congruent by side, side, side. So a rhombus, when I draw the diagonals, I actually get 4 congruent triangles. And then there's something even more specific. We did a unit where we talked about tessellations, and we talked about the vertex of a tessellation is equal to 360 degrees. Well, if I know that these 4 angles are all the same angle, because the 4 triangles are congruent, and I know that they add up to 360 degrees, then I know that those 4 angles are all right. So when we draw the diagonals of a rhombus, what we end up with is 4 congruent right triangles. Okay? So back to this, the things that we know about a rhombus again, all the stuff we already knew, and then the new stuff. We know that the sides are congruent. The diagonals, the congruent diagonals, they intersect each other at a perpendicular line, and they bisect the angles. Okay, they bisect the angles. So the important thing to make sure that you realize here is that when the diagonals are drawn, there are 4 congruent right triangles in a rhombus. So, some rhombus examples. Here we have, this is easy. A, B, C are all the same. So you just got to know what a rhombus is. On the one over on the right, if this angle is 25, so is B. So that's 25. This is a triangle with 180 degrees and 50 are gone. So that makes A 130. and then opposite angles and all parallelograms are congruent. So C is 130. Down here at the bottom, you know, L, D, G, and I, those are all 90. Once you have this is 28, well that's 28 because we have 4 congruent right triangles. So those are all 28. 90 minus 28 leaves us with 62. So 62, 62, 62, and 62. Easy enough. More rhombus examples. If AED is 5x plus 5, that's this angle right here. Well, we know that's right. So 5x plus 5 equals 90. So 5x equals 85. So x equals 17. Here, the measure of ABC is 6x minus 2, and that's the whole thing. And then ABD, actually, let's do this. So this whole thing right here is 6x minus 2. Just this part is 2x plus 10. So I know that this is also 2x plus 10. So 2x plus 10s should equal 6x minus 2. Two of those small angles equal the whole thing. I'm going to divide both sides by 2 again. Again, if this confuses you, talk to your teacher about the algebra involved here. 2x plus 10 equals 3x minus 1, and I get x equals 11. At the bottom, if AB is 5x minus 10, and BC is 2x plus 2, and this is a rhombus, then those are going to equal each other. So 5x plus 10, sorry, minus 10, equals 2x plus 2. Then we get 3x equals 12 and x equals 4. On the next page, there's an area formula for the area of a rhombus. Okay, so it's 1/2 times diagonal 1 times diagonal 2. If you take a look at this example, we get MA, this part right here, is 8. Okay, we also know that that's 8. What we need now is we need the other diagonal. All we're told is that DMA is 30. Okay, you can use special right triangles or trig to find this missing side. I'm going to go ahead and use trig on this one. So I'll say I have the opposite and the adjacent and not the hypotenuse because that's the right angle. So I'm going to say the tangent of 30 equals x over 8. I'm going to go into my calculator. I'm going to make sure that I'm in degrees. And I'm going to do 8 times the tangent of 30. And I get 4.6. We'll round it to the 10th. So x is 4.6, which makes this whole diagonal 9.2. So now my formula is A equals 1/2. Which one's diagonal 1 and which one's diagonal 2 doesn't matter. We'll say 16 and 9.2. So it's really just 8 times 9.2. And I get, well, I put 92, but I know that that's 73.6 is the area. So all of our right triangle stuff that we've learned is fair game, okay? A square is often thought of as like the perfect quadrilateral, so it's a rhombus, a parallelogram, and a rectangle all wrapped into one. So everything we know about all of the parallelograms is true. Everything we know about rhombuses, about rectangles, all true, okay? All true. So everything we have is true about every parallelogram so far for a square. What that lets us do is some really, problems really quickly. We know that that's 90. D and E are both 90. I know that A, B, and C are all 5. Okay. For this problem, we have AB is 12. And then it asks me what AE is. Well, I know this and this are the same. So I'm going to do Pythagorean theorem here. X squared plus x squared equals 144. And I get 2x squared equals 144. X squared equals 72. And if I take the square root of both sides, I get x equals 6 times the square root of 2. So AE is 6 square root of 2. BD is double that, so it's 12 square root of 2, and EC is the same as that, so that's 6 square root of 2. Here, this bottom left problem looks a lot like the rectangle problem we did earlier, where there's all sorts of numbers or letters. But everything we know here, I mean, all 4 of these middle angles, these are all 90. And every other angle, these are all congruent. and they've all been bisected, and they were 90 to start, so those are all equal to 45. It's the nice part about a square is that there's not a whole lot of numbers. AC is 6x plus 12. BD is 5x plus 15. So those are congruent. So 6x plus 12 equals 5x plus 15. So x equals 3. And the directions say to find AC. So I'm going to plug that 3 back into AC, and I get AC equal to 30. If the measure of angle ABD is 9x, well, 9x equals half of 90, so 45. So x equals 5. That's a messy 5. X equals 5. Lastly, the last slide is really just a reminder of things that you can do when finding sides, angles, the diagonals, the value of x. Just some reminders. First, to determine the type of quadrilateral. This is a big deal. Okay, the type of quadrilateral, it's a big deal. Make sure you read directions, pay careful attention to the marks. You want to determine characteristics you know. Make sure you can learn the characteristics you just learned, or you won't be able to do the problems. If you guys don't watch these videos or understand the rules for each different shape, you're not going to be able to do the work. Write the equation, solve the equation, and make sure that if you have to plug back in and find a missing side or find a missing angle, that you do that. All right? Hope you enjoyed the video. Hope you aren't too scared. See you next time.